Hello everybody. Good morning from sunny Zagreb, Croatia, from the southeastern Europe. I see a lot of greetings from sunny everywhere. So sunny Vienna, sunny Umbria, sunny Edinburgh, sunny Vilnius. And this sunny will be the highlight of today's talk. My name is Dunja Macoko-Drvar. I'm working as a senior forecaster in Croatian Hydromet service for lucky 13 years now. And I'm very pleased to host this first spring weather briefing after a long and we will see cloudy winter. So let's move to the talk. So this is me. I have an umbrella on my shirt, but I will not need it for at least a few days now, hopefully. So the arrow shows where I come from. Zagreb is somewhere here in the northwestern part of Croatia. So I would like to take your attention and if you please put a star on your place where you are, where you come from, just to get a small overview of who am I speaking to. Okay, I see a lot of people from the Baltic countries. Some people from the Central Europe also. Okay. Hello, Edinburgh, Italy. Okay, I hope this is it. Thank you very much. I was hoping to see someone from south western part of Europe. You will see in a few moments why I was eager to have someone from the southwest. But nevertheless, we will speak about southwestern Europe as well as the other parts of Europe today. Okay, let's move on. Just a small questionnaire also to get a brief overview of what you are working with, what are your interests. So please put a star again on what are your main interests. Okay. Mostly satellite meteorology and of course related to that extreme weather and nowcasting and short range. Okay. Okay, so nobody of you is working in the long range. Oh, okay, thank you. Okay, this is interesting because I was wanting to see that because I will speak a little bit also of synoptic climatology and take a brief overview of the back and forth of the long range as well. So here is my talk. The content of the talk will be split in 3 parts. The first part will be related to the former 2 weather briefings, which had the part related to the non-existing winter these past 3 months. So the weather briefings of January and end of February had this question, where is the winter? So now, since I'm speaking from the spring point of view, I will look back a little bit and try to find out where was the winter. The second part will be related to a special event which happened just after our last weather briefing, a few days after the former weather briefing, an event with colored rain and snow, colored precipitation in the southern part of Europe, in Mediterranean and Central and Southeastern Europe. And the third part will be, of course, related to the present weather situation. nevertheless, I will speak about yesterday's situation, but we will see the reason for that also. So let's take a look at where the winter was. And this is the reason why I wanted to see someone from southwestern Europe, because apparently from these maps we can see that the winter was here. And this is the only part of Europe which actually had some winter conditions in average, of course. The left-hand side picture is showing the temperature anomalies in relation to the 6190 climatology for October, November, December. I'm sorry about that. October is included because I had no recent picture which had the actual 3 months, November, December, January. But I also put here on the right-hand side the February temperature anomaly, so you can see that more or less it is the same. So we can conclude that the weather patterns were more or less the same as in the former months. If we look at the precipitation anomalies, then we can again see there is some regularity. There is the wet or normal part of Europe here in the western part, and dry conditions in the northeastern and the eastern part of Europe, with the biggest anomalies in the Scandinavian countries, especially Sweden and Finland. And this dry spell, dry anomaly also was present more or less in the same areas in the month of February as well. So I believe that at least most of you, if not all, are familiar with this circulation indices, which we use to explain the circulation, the big patterns related to the Atlantic climatology phenomena or climatic phenomenon. It's related to the fluctuations in difference of atmospheric pressures at sea level. And this is the NAO, the North Atlantic Oscillation. And also we have this Arctic Oscillation Index, which is related to the mid-troposphere fluctuations in difference of the pressure or the gradients happening in the North Atlantic. So the graph here explains or shows the NAO index for the winter months for December, January and February, and we can see that mostly we had this positive phase of NAO index, which is in theory related to this strong low pressure system, Icelandic low pressure, or Greenland and Icelandic, and the storm track is in this case positioned somewhere here, and most of the storms are influencing the northwestern Europe and also the islands of the UK and Great Britain, which would result in drier than normal winter conditions in the southern part of Europe and warmer and wetter conditions in the northern Europe. Nevertheless, this storm track can move a little bit more to the north or to the south, and of course then this line in between those two those two, the dipole would shift a little bit south or north. We can see here that most of the winter, especially the December and February, had these distinct positive values of NAO index, but in January we see that we did experience some of the negative phase of the NAO index, and this would and did result with moving of the storm track more to the south, and then those wetter conditions appeared also here in the southern part of the Europe. Speaking of Arctic Oscillation Index, which is related to the atmospheric pressure at sea level, we see also that we had in December a distinct phase of positive Arctic Oscillation Index, and again this corresponds with the storm track, which is pointing directly to the Western Europe, to Great Britain and Ireland, and most of the storms would, in these conditions, hit this part of Europe. Afterwards, this circulation changed a little bit. We had this negative phase, and then in February, the signal was not so distinct as in the former 2 months. In January, when we had this negative phase of Arctic Oscillation Index, this would, in theory, and did in practice, result with moving of the storm track more to the south, and we experienced a little bit of colder and wetter conditions also in the southern Europe. So I guess you would ask why I am giving so much minutes, so much time to something which is not directly related to the satellite meteorology. But if you worked, and I guess you did work in the operational shifts in the past 3 months, then I guess you saw a lot of similar patterns also in the satellite imagery, as we will see in a few moments. As you probably know, this past winter was the stormiest winter, the stormiest period in the past 20 years in UK, and at least 12 major storms hit the UK in these past 3 months, in December, January and February. So those are the dates when they happened, when they appeared. So we had a few of them, most of them in December. So on 5th of December, then on 18th and 19th December, 23rd and 24th December, 26th and 7th. Then again in the last 2 days of December, New Year's Eve. After New Year, 3rd and 4th of January, 7th of January, then a little bit of a break. And then again, when we entered this positive NAO phase, again we had storm on 26th of January, 5th of February, 9th, 12th, and then 21st of February. So those were the meanest storms that UK experienced in this past 3 months this winter. So if we take a look at this the satellite overview of those storms, we will get a distinct idea that we had very, very similar situations happening for a period of 3 and even more 4 months in this western part of Europe or the eastern part of the Atlantic. So first of all, in this December situations, December was, as we saw, characterized by the intense and extended low pressure center over Iceland, which moved a bit more and a bit more south and a bit more to the north, but the main structures were the same and were positioned in the pretty much same part of this eastern Atlantic. And this mean sea surface level pressure was often below 995 hectopascal, reaching from this southern Greenland to northern Norway. And on the other hand, this high pressure system in the south and southeast part of Europe, which persisted for quite a long time, with mean pressure in the range of 1020 to 1025 hectopascal eastwards and northeastwards. This is the first or the second of the storms that I mentioned. The third one looks pretty much the same. The lower pressure, but not so very low, was over the eastern Mediterranean Sea and southern and eastern countries of Europe, and of course this similar positioning of the storms of the storm centers near the UK and the western part of Europe ground. The highest positive anomalies of 6 to 10 hectopascal were over the central Mediterranean. Again, we see here the high pressure system in the southern part of Europe and a new storm hitting UK on 27th of December. Next one on New Year's Eve. Here we have two low pressure systems, just here and here, another one. So if we go a bit more a bit faster through these pictures, we would see that a lot of those storms had similar positionings. Now we are moving to January, and if you remember, I said that in January this storm track moved a little bit. So now we are experiencing this Icelandic low, which extended far southward. This polar front moving down here a bit. And mean pressure was also below 995 hectopascal, enclosing most of Ireland and Scotland now. So the southern part of Europe experienced also this storms from the Atlantic. There was the gap now in January. We saw that also on the map, on the plots. And again, another nice storm hitting UK on 26th of January, so at the end of January. We are moving to February, and in February we see this distinct greenish air mass, which would suggest that this was the part of winter which was quite warm, so very warm conditions in most parts of Europe, and especially in this central and eastern part of Europe. Again, another storm hitting UK. Here we have this distinct center near Ireland and moving eastwards. Another one, pretty much the same position on 12th February. And this is where things started to move, to change. And polar front finally moved downwards to this southern parts, even further south to Africa. So most of Europe will be in the next few days hit by this, influenced by this cold outbreak, which we see here in the western parts of Europe. So our eyes are finally moving down from this part of Europe here. Sorry, from this part of Europe, or this part, whatever, to this part of Europe and Africa. Well, when we have a cyclone forming and developing in Africa, then our experience says that we can and should expect some dust coming from that part of Europe, so that part of the world, that's northern part of Africa. So this cyclone will take in and ingest a lot of dust, and if the storm track will be again moving to this part here, then we will have some of that dust falling down with rain and snow in this part of Europe. And this means that we are moving to the second part of the talk, to this situation with colored precipitation in Central Europe and Central Mediterranean. So this is the IR image for the day 18th of February. We see that we have a cyclone here. It's not so deep, but it's quite big. Its center is here outside of the satellite image. And of course, in this part, in the frontal part of the cyclone, we expect to see some of the dust ingested in. Of course, looking for dust, we will take a look at dust RGB, which is designed to monitor dust storms, and it is designed to do so also for day and for night. It is constructed of the severity channels IR 8.7, 10.8 and 12.0. And of course, this pinkish magenta color, which we see here, comes from the high contributions from both red and blue components. Reddish color comes from the transmissivity in channel 12 microns, so in IR 12 microns, being larger than 10.8 from thin, non-opaque dust clouds. And the blue, of course, which is related to temperature, also this contribution is from warm, low clouds, which also refer to the dust clouds. If you want to know a bit more about dust RGB, you could look at the dust cal, the training module, which is done by Nuno Moreira from Portugal and his associates. It is available on the EUMeTrain webpage in the section of training modules. So let's take a look at this dust a bit later. So 12 hours later, the system moves as we expected, of course, further northeastwards, and we can now see also the effect of the dust on high-level clouds. So this dust is now masked by the upper level cloudiness. So we can maybe take a look at some other RGB to see if we can see this cloud, this dust in the clouds as well. So the dust aerosols, of course, have the impact on cloud microphysics because the cloud phase and particle size change. And this dust, which is ingested in the clouds, glaciates more quickly. So now we have a lot of very small ice particles in the clouds. And those very small ice particles have higher reflectance than large ice particles. And for that reason, in day microphysics RGB, which is constructed from near IR and the IR, so the 3.9, we can see them more distinct. So in this day RGB, the day microphysics RGB, they appear orange, bright orange. So this is the explanation for the day microphysics RGB from the ePort section. You can see here that this is the color for the small ice particles, which also we have, of course, here in the whole system, and they are moved to this central part of the Mediterranean and the central part of Europe as well. Also, this orange pattern here. Sorry again. In the day microphysics. Also, because of these very small ice particles, we can very distinctly see them in the severe storm RGB or the convection RGB, and they appear bright yellow. Again, we have this explanation where you can see that this bright yellow color belongs to this thin ice cloud particles, and we can see them here throughout this frontal system, stretching from Africa to Central Europe. There are some forecasts, or there are some institutes which, of course, forecast the position of different of the dust and different aerosols in the precipitation. So I found the forecast of the Greek Institute Skiron from Athens, Greece, and it was forecast for the 19th of February for dust to enter this part of Central Mediterranean and Alpine region, and for 18 hours after that to move a bit more to the east and cover part of Croatia and Adriatic Sea as well. Of course, here it is worth to mention that we had this strong meridional flow, which was moving these clouds and then this frontal system from further south from Africa to Central Europe, which is also quite significant for all 3 months, and we saw that also in the circulation systems throughout winter. And this is the result of this meridional inflow of dust to Central Europe. So these are the photographs from some parts of Croatia. This one here, Istria, is in northwestern part of Croatia in the northern Adriatic. So there are some reports from that part of Croatia with black or brown rain falling Rijeka as well in the northern Adriatic, Krk is an island in northern Adriatic near Rijeka. Rabat is also in Istria, so this is the area of northern Adriatic, the area which we saw also in the Greek forecasts that will be influenced by this dust from Africa. But also we experienced some brown rain in northern part, continental part of Croatia, also here in Zagreb, but I have a picture even further northeastward in Koprivnica. And there were some reports also from Munich, so this system really moved in continental part of Europe, in central part of Europe, more than they usually do when they reach just the southern part of Europe or the central Mediterranean. And even more so, it was not only rain which had some dust in it, there was also the snow. So there were numerous reports from the alpine ski resorts which experienced whichever they thought it was, but some said that it was pink, some said that it was orange, some said that it was brown snow, but nevertheless that the snow was colored, and you can see that in these pictures from the Dolomiti part of Alps. So this is another feature which was very related to the same synoptic situation, which one of our colleagues saw. This is kind of a Rorschach test, so anyone can see in this picture what they want to see. But we were somehow influenced from our colleague who said that this is the EUMETSAT tribute to the Olympic Games, because this was, of course, 19th of February when the Olympics were still lasting, and there is this feature which they said that this is an ice skater, or I don't know, so you can see whichever you want to see, but clearly this is the head, and this could be the arms and the back and the legs, so, or this could be someone who is cheering from the Olympic Games, but nevertheless this is something that we wanted to stress out, that this looks as something related to the Sochi Olympics. And of course, meteorologists will see here that this is the position of the low, and this is the reason why we have here this nice hole in the cloud pattern. So moving from this February and winter conditions to spring, we are now entering the third part of my talk, which will be related, of course, to the present situation. The present situation refers to the yesterday's situation. So we will look at the 12 UTC yesterday's pictures. On one hand, because of the personal reasons, I wanted to do that yesterday, so I did it on yesterday's images. But on the other hand, yesterday's situation is far more interesting than today's, because today we have quite dull weather in most part of the Europe, and we see that also from your remarks in the text chat. So everybody is reporting that it is a beautiful day, and usually beautiful days are not so interesting for the forecasters, especially for the satellite discussions. But also one of the reasons why I decided to speak a little bit about the synoptic climatology, or about the climatology of the past winter, is because finally, after 4 months of those numerous lows that we saw and the NAO positive situations, we have a quite opposite situation now. We have a big and distinct high pressure system over the biggest part of Europe. We see it, of course, in the IR image, but we see it also in the mean sea level pressure for yesterday 12 UTC from ECMWF fields, available also in the ePort. So we see that most of Europe is, of course, influenced by this circulation at anticyclonic circulation, and finally this UK and Ireland can breathe a little bit, and they are now relieved from these numerous storms which hit them in the former few months. Also, which I wanted to mention, and why I mentioned this meridional circulations which influenced most of the winter, is to stress out that this also changed now, and now we are influenced much more by zonal flow throughout Europe. And if we take a look at the frontal systems, again on the infrared image, we can see that we have this system, which is of course on the rear part of the anticyclone. So we have here warm front, then we have the cold front, again warm front here, and a cold front here. So this big frontal system westerly of the high pressure system. We also have here a front which is not so distinct, especially in this part, because here in this part of Europe it consists only of the differences in the thermal parameter, and as we see, there is not so much humidity here. So it's a dry front, dry cold front. And of course, we still have the remains of this old system prevailing and moving a bit further south and east here in this part of Europe. Now, to see a feature which I wanted to stress out regarding this warm front. I was a bit surprised when I saw this, and I saw that the cloud system moved far ahead of this frontal system detected by the model, and I wanted to see what's the reason for that. So there are of course two possibilities. One is that this is the system here, and that the model was wrong. But again, it's too far for the model to be so wrong. Correct me if you do not agree with me, please. And the other reason for that could be that the warm shield or the warm band is stretched above all this region. So I wanted to see what the model was, how the model was forecasting the clouds. Of course, we do that by looking at the pseudo IR image, and we saw here that really there is a part of the system which moved ahead of the forecast here, ahead of the forecast cloud system. Similar thing happened here also in the far Adriatic, but far Atlantic, but here it is the effect of the warm shield. If we take a look at the other parts of Europe, we can see that model is pretty much catching all the significant features. Cloud features. Of course, one of the most striking things in this satellite imagery from yesterday are the low clouds. So this is the midday picture, and we still have a lot of low clouds. We can also look at them from the model. So this is the low cloud coverage, the low cloudiness from the model. We see that we have a lot of low clouds here behind the frontal system. So the front already moved further eastward, and behind that we have these low clouds which are related to this northerly and northeasterly flow behind the front. And we have a lot of clouds, low clouds also here in the Atlantic. Which is quite inconsistency to the actual situation. Now, a few of us looked at this image yesterday, and we were surprised to see this gap here in Bay of Biscay. So it was not so obvious for us why we have this gap here, this hole in the low cloud coverage, because of the system which is covering most of this part, and one would expect that the clouds were more filling all of this part here. Sorry, here. So we now looked a bit more to this part of the Atlantic to take a look what happened here. And the first guess is, of course, to take a look at the air mass and see a bit more what is happening here. And of course, we see here that we have this dry air in this part in the air mass. So now we wanted to look a little bit more to the upper levels and see where does this dry air come from. So to see if you are all awake, please let's draw jet streams on this map. Let me just give you the map, the air mass. So this is something that we most of the weather briefings are structured like this. Okay. Okay, is that all? Are you sure? Okay. Now, just to okay, just to see a higher level question. Now let's try and draw a direction of the jet, not just the jet stream or the jet streak, whatever. Just please try to put a sign or the arrow or whatever in which direction this jet is pointing. Okay, okay, most of them are okay. Okay. Okay, this one in the northern or northwestern part is quite obvious. Okay, okay, thank you very much. Nice drawing. Let's take a look at the solution. I erased that and I shouldn't have. Anyway, we were right, you were right about this one here. As I said, this one is very obvious, so I would not put so much attention about it. Of course, this is something that is related to the frontal system, and the frontal system is moving ahead or is situated on the right-hand side of the jet. The other one is one here, and the other one here. So this is also something which is very obvious and is related to the waves, to the polar front. We had some of the answers also in this part of the world, so I'm very pleased to show you that you were right again. This one is a bit more to the south than you suggested, but anyways, the position is okay. And there were some guesses that this here is also a jet, but as you can see from the model, it is not. It is the dark stripe, which can be nicely seen in the water vapor, of course, for the upper levels. So regarding the direction of the jet, you were again mostly right. This one in the upper levels is, of course, the westerly. The one over Africa is also westerly, and this one here, which is quite interesting to see, is the easterly jet. Now Ivan told me that I don't have so much time anymore. I spend most of the time on the climatology, so sorry about that. We are moving a bit faster to see this part of the picture, which we were so eager to see what is happening here. And of course, now when we go to move to the water vapor, there is no chance that you would miss this here. This is something related to the water vapor, obviously. So can you please write in the text chat what do you think that is? Or you can write on the map, whatever. Eddie? Upper level low. Okay, so okay. Eddie and upper level low. And the third one would probably be correct. Stratospheric air damming, it's true, but what kind of a conceptual model is that? Water vapor R. Okay, Renato, you are the winner. This is the water vapor I. And since I do not have so much time to explain that, I will show you the brief overview of the conceptual model of the water vapor I. And you will be, of course, pointed to take a look at the conceptual model in the Satmanu and look a bit further into that. So water vapor I is a feature which comes from initially old dark stripe, and is of course associated with the former baroclinic zone. And during its development within the huge system of the high pressure, cyclonic structure forms. So if we look into the key parameters, one of the most distinct key parameters is of course the PV. We see the PV, a small trough here and a small low, very distinct. There are some other key parameters, but they are mainly related to the high pressure system and of course the geopotential height, in which we see that within the big high pressure system, a small low pressure system can appear, and it is mostly related to the stretching stretching of the system. So here in the streamlines, you can see that we have here cyclonic movement. We were very lucky to have this water vapor eye in the position where our predefined vertical cross sections in the ePort are. So we could take a look at this here vertical cross section. It's coming from south to north, and our water vapor eye is positioned near the end of the vertical cross section. So in the vertical cross sections, we can clearly see that we are expecting the lowering of PV, even to the heights of 500 and 400 hectopascal. So this is something that we have here. So this is the position near the end of the vertical cross section where our water vapor eye is, and of course the dynamical tropopause. So some of the answers were also correct regarding to this stretching of the tropopause or the stratospheric air damming. We also have one of the parameters in vertical cross sections, the omega, or the vertical motion. And of course, we see here the vertical motion due to the increase of the vorticity advection with height, which is appearing in the upper levels here. And we also have at the rear of the system the downward motion related to the negative vorticity advection. And of course, in this part here, we would expect then dry air. So this dry spell at the rear of the system. So this is the also the pseudo water vapor image, in which we can see that the model captured that quite well. We have this water vapor eye also in the modeled water vapor image. And the reason for that is also obvious. This is the 500 hectopascal wind from ECMWF model. We see here some cyclonic movement, and of course this is the reason why the model was able to predict that here we will have this dry conceptual model. Looking at the overall situation over Europe yesterday noon, one would probably say that this part of Europe is very cloudy. Would you? I mean, if we look only at the IR image, and remember we are in the zenith of the sun noon conditions. So here we have quite a lot of clouds, we would say. But if we look at some other type of the satellite product, for example, at natural colors RGB available at noon, we see that this is an overstatement and that there are not so many clouds in this part of Europe, especially in Croatia, most of the Balkans, and also most of the Mediterranean Sea. So why is that, and what happened here? We can go also a bit more into that. I have still 3 minutes. Here is the 24 hours microphysical RGB to show you also that there are actually something is happening here in this part. So there are a lot of clouds here, but they are consisting of very, very, very cold small ice particles, which also suggest that this is very, very high level cloudiness and is very transparent, so it is not seen either from ground nor from the natural colors, for example. The only part of cloudiness which is well captured is, of course, this part where clouds are above cold ground, above snow, or above remaining frontal cloudiness. So where the background for the higher clouds is colder, and this distinct cyan color then can be seen. And here in this part where it is over warmer ground or even more so warm sea, these high clouds cannot be distinct. The model also captured this quite well, so we could see from the CMWF model, for example, in the cloudiness, that this orange pattern is the low cloudiness, the magenta is mid-level cloudiness, and this biggest part of this cloud system is related to higher clouds. Okay, I'm on time. Thank you very much. Next briefing will be held on April 10th, 9 UTC, of course, and of course keep in mind that this will not be 10 local, 10 Central Europe, then it will already be 11 Central Europe, and it will be held by Angela Lourenço from the Portuguese Met Institute.